Welcome to EDU World Space.
Problem 3.114. In this problem, we have to find single equivalent force, and that is because of that may act because of these three forces that is acting on the system. So first of all, we would have to define a coordinate system. So let us say this is our y direction and this is our positive x direction. So we can write all the forces according to the x and y component. So if we go to calculate the equivalent moment that is acting on the system, so this will be this 10-pound force is acting in negative y direction, so this will be minus 10 j cap. This 25-pound force will have two components, one along positive x-axis and one along positive y-axis. So if we talk about the positive x component, this will be 25 cos 60. So this will be plus 25 cos 60 I cap and plus 25 sin 60 j cap. Now this 40-pound force is acting in negative x direction, so this will be minus 40 I cap. If we collect the coefficient of I cap, j cap and I cap and j cap, since there is no k cap, so this equation becomes minus 27.5 I cap plus 11.65 j cap. So this is our equivalent force that is acting on this system. So this was the part A, and in part B they are asking that where this force should be applied on line AB, so that there is no moment, since we have to replace a single by the single force, single equivalent force. So first let us draw a rough sketch of the equivalent system. So this is our equivalent system in which this is point A, this is point B, and this is point C, and let us say that our equivalent force is acting at this point, which is at a distance of D from the side BC. So if we draw here the equivalent force, I cap component is negative, so we can draw the I cap component in left direction and its j cap component is positive, so it will be in upward direction. So this component will have a value of 11.65 pound, while the x component will have a value 27.5 pound. Now if we calculate the moment in actual system about point B, so moment because of this 25-pound force will be 0. So the only moment will be because of these two forces and the moment that is acting here. So considering the counterclockwise direction to be positive, this moment is already in counterclockwise, so this will be plus 80, and this 10-pound force will cause a counterclockwise couple about point B, so this will be plus 10 multiplied by 12. And if we talk about the moment because of this 40-pound force, it is in clockwise direction, so it will be negative 40 multiplied by 8. And this moment from the actual system, this must be equal to the moment in the equivalent system. So if we calculate moment in equivalent system about point B, so this 27.5 pound force will have no moment about point B, since its line of action is going to pass through the point B. So the only moment will be because of this 11.65 pound force, and that will be 11.65 multiplied by D. So in this equation there is only one unknown, and that is D, so we can get the value of D, and D comes out to be 10.3 inches. Now in another part of this of the part B, they are asking that where this resultant equivalent force should be applied on the side BC, so that the only resultant force is itself enough to cause the same effect that is being caused by this system. So again we will draw a rough sketch of the equivalent system. So let us say this is point A, this is point B, and this is point C, and our equivalent force is acting at a depth of y from the line AB. Now if we draw the vector that is a resultant vector here, since again this I cap component is negative, so force will have negative value in x direction, so this will be 27.5 pound, and the y cap component will be in this direction, and that is 11.65 pounds. Now we can again equate the moment about point B that we have just done previously. Here the moment about the point B, now considering the counterclockwise direction to be positive, so this was the moment in actual diagram, so we can use it directly here as plus 80 plus 10 multiplied by 12 minus 40 multiplied by 8. Now if we talk about the moment in the equivalent system that we have just drawn here about the point B, so this 11.5 pound force will have no effect in the calculation of a moment, since its line of action is passing through the point B. The only effect will be because of this 27.5 pound force, and it will cause a clockwise couple, so we will use negative sign here, minus 27.5 multiplied by y. If we solve this equation, y comes out to be 4.36 inches. So if this equivalent force that we have calculated in part A here, if this force is to be placed on the side AB, then it should be at a distance of 10.3 inches from point B towards the left, and if this equivalent force is to be placed on the side BC, then in that case it should be at a depth of 4.36 inches from the point B along the side